Hey folks, happy Thursday morning to you here. Uh, Today we keep on rolling, so to speak. We're going to see notes on the third type of collisions for us. This one's a little unique, a little different. Um, your quiz for Monday and Tuesday will include two of the first three types of collisions. I know that's not real informational, but it's the best I can get you right now. Okay, meaning that you'll have at least one problem, or at least one problem from two of those three. Okay. All right. So here's what we got. All right. Here are the different formulas that we have. I know I showed this to fourth, fifth, and sixth hour yesterday, but these are the different formulas that we'll be using for kind of the foreseeable future here. Right? Most of these look pretty darn familiar. Obviously, the top one is becoming more in tune to what we're using. Otherwise, you see the various work equations. You see the total mechanical energy one at the bottom. The force friction one is the third one from the bottom. All right. So here we go. All right. Type 1 and 2 versus type 3. So when we look at type 1 and 2 versus type 3, type 1 and 2 are very similar. Please understand that. All right. Meaning that for those two, really, we can work with the momentum, kinetic energy. The difference becomes that type 2, obviously, there is friction in it. All right. For type 3 now, the difference becomes we're still hitting a stationary object. Okay? That's no different. So we still have one of our objects at rest. Instead of this object sliding, once the impacting object collides with it, now what we're going to see is that the two ropes are going to cause this thing to curve upwards and get some certain amount of height. Okay? This upward movement, we're not going to be able to use our force times our distance because we're actually getting a vertical climb here. We have to use the change in GPE. Okay. Momentum is still for us in all of these. So what does it look like? Now, this is bullet and block again, but this is bullet and block with a pendulum, right? So the bullet's going to have its velocity and its momentum still, all right? That'll still be there. So again, the path that we can take is we can say, well, how fast is the bullet going? Okay. That could be a question that we have. All right. This is converted into height once it's embedded into the object. Right. So we see that thing lift up. So what we see is that the amount of kinetic energy that this bullet has as it hits the object is immediately started to turn into gravitational potential energy. Because what will happen is that this thing will rise up, it'll hit its apex, and then it'll slide back down and kind of bounce back and forth. So if you've ever seen like a grandfather clock, if you've ever seen, what else is a pendulum? Somebody trying to hypnotize you with like a watch or something like that. Those are all kind of examples of it. So what we end up determining here is our height. Height becomes very important for us, right? So the way that we can run problems here, all right? If the initial velocity over here of the bullet is known, guess what? Then what we can do is we can figure out how high is this thing going to go, all right? If we are able to determine the height of the actual object here, then what we're able to do is say, okay, how fast was that bullet going in order to enable it to reach that height, okay? So if we know the height of the block and bullet, we'll use GPE at the contact. This allows us to turn that into kinetic energy. Again, remember that total mechanical energy concept. In order to get up to the top of that height, what we have to have done is converted kinetic energy into gravitational potential energy. Once we know from that height how much kinetic energy started this thing, well, then it's just like type 1, or it's mostly like type 1 because we don't have any friction. So, all right. So that's kind of what we're looking at here. Okay, so here's our problem for you. Okay. So if you want, go ahead, pause, write down your information here because you got a 50-gram bullet, 1.3-kilogram block that is suspended from the ceiling with two strings of equal length. The bullet becomes embedded in the block and causes it to raise 4.5 meters. Now, as you look at this, you got what, 2, 4, 6 prompts and 3 numbers. So immediately, once we start looking at this thing, it gets a little dicey because there's a lot of questions, but a little bit of information. Okay? So we convert stuff. 50-gram bullet, slide the decimal 3 to the left. That's going to put a 0 in front of the 5 and make it 0.050 kilogram, right? The mass of the block is a 1.3 kilogram block, right? That's good. The height that it reaches, 4.5 meters, all right? So then it says, well, calculate the GPE of the block and bullet as it reaches 4.5 meters. Perfect. We've done stuff like that before, all right? So we take the block at 1.3, we take the bullet at 0.05, add those two together to get 1.35, multiply it by 9.8, multiply it by 4.5. We see that the gravitational potential energy of this block and bullet to get to that height is 59.54 joules, right? So once again, that's how much energy it took to reach the apex at that 4.5 meters, all right? Where did all that energy come from? Well, it came from the impact and it came from the kinetic energy of the two, all right? So to determine the kinetic energy of the block and bullet just after impact, all right? Well, when we look at this, at the top, the kinetic energy is going to be 0. Bottom, the gravitational potential energy is going to be 0, right? So because those two are 0, that means that all of this gravitational potential energy, all the height that it reached, came from all the kinetic energy that it started with. So the moment after impact, it had all of this kinetic energy that immediately began to turn into gravitational potential energy. All right? That's just our total mechanical energy one, the bottom equation on that first slide. Okay? So we see all of that energy is transferred there for us. All right? Part C. Calculate the velocity of the bullet and the block just after impact. Here again, we've got a couple different paths we can take. If we know the kinetic energy of it, right, then we can use that to find the velocity. Some of us may try to use momentum. Well, the hard thing is that we don't know momentum yet. We have no idea what that is yet. But we do know what the kinetic energy is because we found out how high this thing went, all right? So we take our 59.54, that's equal to a half times the bullet on the block, both of those together, right, times our velocity squared. So we take 59.54 divided by 0.675, so 59.54 divided by 0.675, that gives us like 88.2. Square root that. We see that just after the impact, so just as soon as this bullet hit, we saw 9.4 meters per second, right? Now, in the beginning, it was going 9.4, but as soon as it reached that apex, it was going 0, right? Because all of the kinetic energy was lost, energy of motion was lost, and all the gravitational potential energy was gained, height, okay? Part D then, calculate the momentum. If we know how fast it's going, we know how much momentum it's going to have, right? Again, the energy is not going to be the thing that we use to change over to just the bullet to find its velocity, right? We can't do that. We have to be able to say, okay, momentum is going to be 100% conserved, all right? So what we do is we take the block and the bullet together again at 1.35 and we multiply it by 9.39, the velocity we just found in the previous one. Okay? Once we know the momentum of the bullet on the block, which is 12.68 kilogram meter per second, now what we can do is say, okay, where did this come from? Well, if the block is just suspended in the air, it did not come from the block. It had to have came from then just the bullet, all right? So determine the momentum of the bullet prior to the impact. Well, all of that great momentum that we use, that 12.68 that was kinetic energy, that turned the kinetic energy into gravitational potential energy, that turned it into height, how high this thing went, came from the bullet, right? So once we know the bullet's momentum, then what we're able to do is say, all right, let's find the velocity of the bullet. So we take the 12.68, which was all the momentum in the beginning. So just before this thing hit the block, we saw that this bullet had a momentum of 12.68. This instant before, right? We divide that by 0.05, and what we end up finding out is the velocity of the bullet prior to impact the block was 253.53 meters per second. All right? Here's the nice thing. once we know the velocity of the bullet on the block, like in step, what was it, C or D, then it's the same type of equation, right? We've done this last step, we've done the previous step, we've done the find momentum step, we've done that a bunch of times. So hopefully it's getting a little bit easier for you. All right. Make sure you take some time. Make sure you get out and do the practice. Also, maybe give a shot of the homework for this stuff. All right. Talk to you.